Hello, hi everyone. Good evening. I hope my screen is visible to everyone and I am audible as well. If yes, can you just quickly drop a hi or a thumbs up in the comment section so that we can start? Also, I can also see a lot of comments are already there with respect to access codes and everything. Okay. Great. So, hello everyone. I am Shweta, and a huge welcome to the second hands-on workshop under AI for Bharat program. Today, we are going to learn about building context-aware AI applications with RAG. Now, for those who are new to this program and who are joining us for the very first time, AI for Bharat is a structured two-phase AI program exclusively for the developers in India and completely focused on providing hands-on upskilling opportunities through curated workshops and challenges. So every week, a new hands-on workshop goes live with a different topic where we learn different things. And to perform these hands-on labs, you need the access to the AWS Workshop Studio, and for that, you need to book your slot. So every week we give you three options: Tuesdays, Thursdays, and Saturdays, 4 to 7 p.m. And apart from this 3 hour window, it can be extended up to 48 hours. So by booking your slot for a particular day for that particular week's workshop, you get access to AWS Workshop Studio's lab environment for 48 hours, in which you can complete the lab, submit the screenshot with a published technical blog link on AWS Filter Center, and that makes you eligible for the AI for Bharat certificate. So every week, different lab, different topic. Make sure that you book your slot because only people who book their slot for a particular time period, either for Tuesday or Thursday or Saturday, they only get the access links or the code so that they can enter the AWS Workshop Studio and actually perform the workshop live. For workshop 3, since we are in week 2 of this program, and today we'll be doing the second workshop, for workshop 3, which will be going live next week, the slots are already opened. You can log into the program dashboard and book your slot that works and fits best into your schedule. And during this time, if you're stuck somewhere, you can A, first watch the recording on the workshop of the workshop on the program dashboard, and B, reach out to the AWS experts on the Discord channel. We'll be circulating the Discord channel link again in the comment section so that if you haven't already joined the channel, you can join that. So for those who have booked today's slot, you can complete the workshop along with the speaker live today itself. And for those who have booked Thursdays or Saturdays slot this week itself, for them, we have expert help available at the AWS Discord channel from 4 p.m. to 7 p.m. At other times as well, you can drop in your queries, but you can expect a delay in the response. So that's all when it comes to weekly workshops, slot booking, and earning a certificate as well. Moving forward, we also have Kiro weekly challenges. So every week, a new challenge is launched. For example, last week, the challenge was around micro tools. And this week, it is about lazy automation. And as the name suggests, it is about building something that automates your daily tasks that you absolutely dread doing. For example, renaming 100 files, organizing desktop clutter, summarizing emails, and much more. So this the challenge that is currently live. All you have to do to be eligible for the amazing rewards, you have to build something using Kiro, and as per this week's challenge, and submit two things on the platform. One is the GitHub repository with .kiro file, and second is a technical blog published around how you have actually built with supporting documents like code snippets or pictures on the program portal. So once you submit both of these things, your GitHub repo and the technical blog as well, every week we announce three top winners who win amazing swags like mechanical keyboard, mouse, smart Gabbit ring, and Mokora backpack. As I mentioned earlier, this week's challenge is already live for Kiro Weekly Challenge as well. So start building and get one step closer to upskilling and winning amazing rewards. Moving forward, let's invite our speaker for today. We have Jitesh here. Jitesh is Customer Solutions Manager at AWS, and he will be taking us through today's workshop. So, hi Jitesh, how are you?
Hi Shweta, I'm good. How about you?
All good.
Hi everyone. All right. So you take over, Shweta.
Yes, yes, definitely you can start. I'll stop presenting my screen. You can start.
Sure. All right. I hope my screen is visible. Shweta, can you confirm?
Yes, yes, it's visible.
All right. So, hi everyone. My name is Jitesh Udwani, and I'm a customer solutions manager here at AWS. In my role, I closely work with customers across different industries, helping them navigate through their cloud journey, whether it is about modernization, migration, or increasingly today, how we see it that they want to adopt generative AI in their business. Now, over the last year, a big part of my work has been guiding customers on how to use their own organizational data securely and effectively using Gen AI. And that's where today's topic is where we stand, which is RAG with Amazon Bedrock Knowledge Bases. This is where it plays a key role that how organizations can use their own data to build the knowledge bases and utilize it with RAG. Now, in this session, I'll walk you through what RAG is, why it matters, and how knowledge bases in Bedrock make it much simpler to build accurate and enterprise Gen AI ready applications. Now, and that too also without having to manage their own infrastructure. I'll share real world patterns, best practices related to it, some hands on examples that I'll be covering today will be around chunking, how you can split the data, how the embeddings are created, where do you store that data. We'll be talking all about that very soon. Now, after this session, you will have a very clear idea of how you can start applying these things in your own environment. So I'm quite excited. Let's get started, and thanks again for taking time to join this session. So before we get on to the hands-on part, I want to cover a bit of basics around it. What is RAG and how it actually works. So here is the basic idea that you see it on the screen, and that's a very simplest workflow. We are not talking about any particular cloud example. We are talking about how RAG works in general. In general, so RAG is retrieval augmented generation. So if you look at the flow that I'm sharing over here is it's an AI framework which allows you to store your data at a particular storage, and you fetch that data and utilize it to build the give the context to your prompt into the LLMs before you directly give a query to a user. So the flow starts by loading those documents, creating the chunk of those documents, and then creating the embedding of those documents. All this gets stored from step 1 to step 4. All this gets stored in a vector DB. From there onwards, if the user is having a query, which is like just like you ask any LLM model a query, it goes back and based on its own knowledge, it builds up the answer and share it with you. However, in this case, before giving the answer to the user, it will get the context for that query. It will see that whatever information that is available with my vector DB, get the embeddings, get the chunks for that, and then finally provide that context to the LLM model that use this context and then build your answer for it. Don't directly just share the answer with the user. So a quick example I can take over here is that let's say I go to any LLM model and I ask a very simple question saying that how many sick leaves do I get in each year. Now, this question might be different for every organization. Some organization might give 10 days, some give 12 days, some give 15 days, and everybody will have a different policy. Now, LLM would be able to answer it, but it would be only able to answer it on the data on which it was trained upon. But we don't want to completely rely on that data because it might not be 100% accurate, and that is where the hallucination comes into the picture. So how do we avoid that part? How about we tell our LLM model that before you answer any question, here is my organization data, go through it, see if you find any relevant information from it, and use that information and then build your answer. So that is where this entire retrieval augmented generation comes into the picture. This is what we call it as RAG in AI. Let's now understand it in a more. I've tried to kept it as simple as possible for even people joining out there who are quite new to this one, may not have complete idea about it. So how it used to work in the initial models which we used to see 1 or 2 years ago, when these LLM models came into the picture, a user used to ask a query like, hello, I want to know this particular question, and the foundation model used to respond to that answer, and that is where you see this first stage, right? And then the second stage is where we do the prompt engineering. And we'll talk about this prompt engineering as well in one of the workshops. We'll modify our prompts to say that, okay, behave like a financial assistant or behave like a technical assistant in this case. So in a simplest way, what we are saying is that before answering the question or before providing that question to the LLM model, we are saying that whenever user asks a question, we are telling our LLM model to pick a persona and behave like that persona. So if I'm asking a question related to finance and I've built that model around that financial activities, I will ask, I will provide it in the prompt itself that, okay, you are a financial advisor, or you are, in this particular case, what you're seeing in the screen, on the screen is, think like you are a civil engineer and you have experience, you have city experience with almost 15 years or 12 years, and now you have to follow these three rules before you need to answer. That's called prompt engineering, wherein, like, before passing on the user query to my LLM model, I am modifying the prompt to behave in a certain way. Now, I can control information up to an extent using this method. I can expect my LLM model to behave in a certain way. That's one thing. But is my information will be grounded or relevant to what the question is being asked? I would still not be sure. That is where this third stage comes into the picture, where you have RAG to say that, okay, this is my query. You have to behave like a civil engineer, but also answer the query only based on the information that I am providing you to you in a RAG database. And now on top of it, this is the dynamic database. We can provide our organizational documents, store it in a particular location in a vector DB, create chunks of it, and then the LLM model can actually use it. And the last stage is that finally I have the RAG, everything created. I have modified my prompt in the stage two. Last stage is that I can retrain and continue to retrain and fine tune my model on the new and updated data. But our scope for this today's workshop, we will be covering up to RAG to see that how RAG plays an important role in this case. Now, before we dive into the hands-on, and this is, I promise you, this is the, before we do the hands-on, this is the last slide that I'm talking about. After that, it's almost the hands-on, and how we'll see that how RAG works in action in this particular case. Uh, okay, all right, knowledge base is visible. Yeah. So if you look at it this way, I have explained you the flow from left to right. If you read the flow, the user asks a query, it comes to the ingestion model, and that is where we see that it goes to the knowledge base, which is Amazon Bedrock knowledge bases, and that is where we'll be storing all those document and information that I was talking about. From this one, it will try to pick up the relevant chunks of that information and then augment the prompt that we are already sending it to our model. Now, the model could be anything. It could be Meta, Anthropic, Amazon, or any other model. But in this case, before providing the query, only the user query to the model, we are augmenting the prompt and we are providing the context that we have picked up from the knowledge bases here. And then finally, it gets shared with the model, and the model is able to answer it much more accurately and effectively with a more relevant context. Let me now stop sharing and come back to the demo part. All right, I hope my screen is visible. Now, before I begin with the demo, I want to cover one more thing, that I hope you all have got an email which looks something like this, which will tell you that in this email, you will have access to your studio lab, that which we will be trying to access. Now, in the email itself, you will have a unique access code link given to you. So look for that email, use that link to join the workshop, and this link would be unique to every team that would be logging into these workshops. These workshops will be available for next 48 hours only. There is no way for us to extend these workshop timings or reframe it again. So try to complete these workshops in 48 hours. There, especially this particular workshop, if I talk about, there is too much of content in this workshop which you will be doing. For me, it would take at least like 3 to 4 hours to cover the entire workshop, but we will not be able to cover entire thing, but we'll try to cover almost all the key topics that are there. So if you look at the workshop, we'll start with the RAG concepts, understanding how RAG works, how we build knowledge bases and open search service collections, how we build vector databases. We'll understand all this in module one. And then in module two, we'll try to understand that how do we optimize the accuracy. Now we have built the RAG, but I want to optimize how optimize the accuracy of my responses that are coming back, or the chunks that I'm retrieving from my vector database. Then how do you make the AI responsible? And this is a key important module, at least in my understanding, because these days we need to be very careful with the AI. We need to be extra ensure that whatever question that is being asked to the AI, whether AI is supposed to respond to it or not. Now, this could be about anything. This could be about any random question that we are asking. And this is where this bedrock guardrails comes into the picture. And we'll look at it in the hands-on workshop as well, that how those guardrail plays a role in limiting the responses or stopping the responses for a particular question, or if there are any harmful words that are being used, how do I make my LLM model not respond to those questions? So we'll talk about that as well. And then lastly, it's about structured RAG. Let's say that you have a structured database, could be your Redshift database, where you have everything in a relational model stored, and you want to build a model on top of it to say that my user doesn't know how to write SQL queries, but I want to query that data, run those queries. So to do that, you use the structured RAG, which allows you to ask queries in a human written language, and it automatically converts those for you in a query that can be initiated to the underlying Redshift or any other database that you would have. And then finally, the graph rack. We'll talk about this as well. Graph rack, I hope you folks are aware. If not, just do a little bit of internet search on this one. You will find that it's a database where you store information in a graphical format, and visually you would think that it's in graphics, but not graphics. The information is still stored in the text format, but it maintains the one-to-many relationship between those informations. So we'll see that as well, how that works. Now, without any further ado, let's quickly begin and do this workshop live. Okay. So once you have landed to this page and you are able to log into this one, the next step is to click Get Started. Click on Next. We have already discussed on this, and you are already doing it at an AWS event. So you will see that we need to see, you can skip this particular part because this model access part is now automated. We don't have to enable models in this case, but we still need to do the SageMaker console part. So before you follow the next steps from the SageMaker part, access the console from here. On the left hand side panel, you will see that AWS account access section is there. From this section, you will click that Open AWS Account Console. Wait for a few seconds and it will open up the console for you. When you open up this console, you might not see any of the recently visited services, because I was accessing this workshop even before this one. So I see that recently I visited SageMaker. But if you don't see any services, just type SageMaker over here. Go to Amazon SageMaker AI. Okay, don't get confused between Amazon SageMaker and SageMaker AI. You need to go to SageMaker AI because that is the new name of our SageMaker studio. And finally, once you reach this particular page, you will see that there is already a user profile created for you, which is SageMaker user. You just click on Open Studio. It's already pre-provisioned for you, all the info and everything. Once you open up the studio, it will tell you that which workspace that you want to work in. Click on Jupyter Labs. You can click it either from here or from here. It's the same thing. And that you will see that there is already a Jupyter Notebook or Jupyter Lab deployed for you. However, you will see one button, which is a Run button. So when you click on Run button, it takes 1 or 2 minutes to start the lab. And once it has successfully started the lab, once it comes back into the running stage, then you will see Stop and Open button. Now, once you reach that stage, you will click on Open button, and this will launch the Jupyter Lab environment for you. This takes few seconds, probably a minute to load. And you see that finally your environment is loaded. Now, this is going to be a very code heavy exercise that we are going to do today. So any questions, feel free to ask it on the chat and we'll try to answer as much as possible on that. I can see one question. You need to click on AWS event because that is what we are doing in a self-managed. We don't have to select self-managed in this case, because self-managed section you can use if you are doing it in your own environment. All right. Now, the first step that you are going to do it is open up a terminal over here. Let's go back to the steps that are being recommended. We have already clicked on Jupyter Lab. We have run this lab. It is in running stage. We have then opened up the lab. And the next step is to download all the code samples that we are going to run today or utilize it from the GitHub. There is already a link that is given. You can pick it up, go back to your Jupyter Lab instance. Sorry, this one. I'll close the extra tabs that are there. And then just paste the code and run it. So what we are doing it here is that to utilize WAG and to build all that infra manually, there is too much effort. So what we have done it is that for your ease of learning, to understand that how WAG actually works and you don't have to build everything from scratch, these scripts will do it for you. You just have to utilize those scripts. So now that I am under this directory, user default DFS, if I get into inside this directory, let me zoom in a bit. I think it would be quite small. Let's see if we can do this. Yeah, I think this is much better. This should be much better and much clear. Yeah. All right. Now you see that a directory has been downloaded and I see RAG workshop Amazon Bedrock knowledge bases. I go inside that, I see the same structure as per my lab. So I will see different Jupyter notebooks that are pre-created for me. We'll be utilizing those notebooks to run these models and see that how RAG plays a role in this. Let's start with the first one. Let's go to the first RAG concept and we'll click create ingest documents. Now, the idea behind doing this particular lab of module one is to understand that how we are creating the knowledge bases. So we talked a lot about what are knowledge bases, where you store your data, and how your models can actually pick up data from those knowledge bases. Now, in this particular case, we'll see it live that how you actually build that knowledge base. If you look at this particular diagram, I'll put it on a bigger screen for you. Let's do big. Let's do this. Yeah. So if you look at it this way, we'll be learning that you have some new organizational data. It could be stored in any data source. That could be S3 or any other storage service where you are storing it. With the help of the code that we are going to run in this workshop, we will convert all this in document chunks. So we'll split that data, big data, into small document chunks, which will then get converted into embedding models. So embedding models, I hope you folks are familiar with it, that internal to it, embedding models are nothing but numerical codes that you get created for the documents, and that gets stored finally into a vector store, which is going to be a vector DB. So that once the data is being pulled out, you can fetch those details directly from vector store. Now let's see live in that environment how that happens. Now, before you do anything, you need to do a pre-setup of this environment. So what I'm going to do it is I'm going to run this command so that it will take 1 or 2 minutes to run, and then I'll explain that what we are actually doing in this command. So while it is running, you see that what we are doing it is we are covering the dependencies, whichever that is needed, any packages or any modules that are needed to run this workshop. And all those have been listed out in the requirement.txt. Now you can easily go back to the home directory and you can see that there is requirement.txt that is present over here. You can also open it up and see that what are the packages and what are their versions which we are downloading. So it's all out in the front. Now, once this command gets completed, the next step is that, and you will see some deprecated messages or messages like this could not be resolved. You can safely ignore those messages because it would still be able to overcome all these modules, all these modules that we talked about in requirement.txt. So don't get too worried about any red messages that you would see over here. Let me also make this part a little bit bigger because, yeah. Is it better now? Can you give me a yes, no on the chat? All right. All right, finally we see that it is moving out. The initial steps will take some time, but going forward, when you are running this thing, you don't have to run this multiple times because we have already installed the dependencies. Though in every workshop, you will see that this command exists, but we don't have to run it in all the workshops. You do it once, your kernel is updated with all the packages, so you don't have to run it again. The next part would be to restart the kernel, and finally we'll start importing the packages that we have downloaded in the requirements. Now this is going to be straightforward. It won't take much time. It will just pick up the current path where we are located, so that it will be able to use that path to import all the modules into this lab. And finally, we'll setting up the clients for Bedrock. Because in this case, we are going to use Bedrock. We need to ensure that we are able to connect to the Bedrock in the system, and we see that we are able to connect to this particular account. This is our account ID, and finally, which region that we are connected to. Now, if you want to validate this particular information, the simplest way is to go back and see that what is the account ID that you see on top of this. And this is the account ID that you will see. And finally, let's come back. Account ID we already shared. We already also talked about in which region that we are using this workshop. You are in US West 2. So ensure that these things are confirmed and you are into the right account and using the right region for it. All right. So the next step is that I will build out certain variables, because considering I'll be creating a new knowledge bases for this one, I need to build the naming convention for those knowledge bases. So I'll be, to avoid any name conflicts, I'll be suffixing all those with a timestamp. So in this particular step, we are just creating the variables for to be used as knowledge bases. We are just attaching and saying that my bucket name will be my knowledge base name and combining with the account ID. So it's only the concatenation that we are doing and building the variables for it. And finally, once that is done, we'll validate that what Boto 3 version that I'm on to. Now the next step is that as part of this workshop, what we are going to do it is we see that there are multiple sources which we can utilize where our data gets stored. That could be our S3 bucket, could be Confluence or SharePoint or Salesforce or any web source as well for that matter, if we are getting it from a web page as well. But for the sake of this lab, we'll do it only for S3 today. So you see that, but if you want to learn, if you want to experiment, there are examples that have been shown that if you have a Confluence site, how you can utilize that. So the examples will already be given. Then finally, we go ahead, run this one. So this basically creates our data source, that what is our data source, which one is our bucket from where we need to pick the data. And then the next step is to create a knowledge base. And this is the step which I was talking about earlier, that in this step, usually you have to do all these things manually, like creating a bucket or putting data into the bucket, uploading all these files. But all this has been created for you. You are creating the bucket with the script. You are creating a knowledge base execution role, which would allow these executions to occur. And then finally, you are creating the OSS collection, which is open search service collection that you would have for the vector DB, which we talked about. And for the folks, if you don't see stop or open option, you need to run the lab first. You need to click on run button, wait for a minute. Once it gets started, refresh the page, you will see the stop and open option. Now, in this particular stage, if you see that we are creating this collection, and to validate all these things, you can actually go back to your AWS environment and just type in S3 and see that if there is any new bucket that has been created. So if you look at it, a new bucket has been created, Bedrock KB 210, and this is the timestamp that has been added automatically. And this is the variables that we created for the timestamp suffixing with the name of the KB. Now, at this same stage, there is a knowledge base as well that will be created. So let's quickly just see that what is the knowledge bases that has been created. You can click on Amazon Bedrock feature knowledge bases. So as of now, I don't see any knowledge bases created yet because we have not reached that stage. We are creating only the OSS collection and then the knowledge base part will come into the picture. But you can always go back on the console, see how live things are happening. Like for example, we validated for the S3 bucket, the S3 bucket is created. Now at the same time, let's validate because I don't think so there will be any files in this one because we are yet to upload those files. So you will not see any objects right away in this one because there are steps in this workshop, upcoming steps. Right next to this one, we'll be using this step to upload all the data to this bucket. Now, the data also that we are using to upload this to this bucket, you would find it in the same code examples that you have downloaded. On the left hand side, you would see that there is a synthetic data set, and in this one there are certain files that we are having. We will upload these files. You see that we are uploading an entire directory. This usually uploading part is quite quicker. The only time consuming part that you will see is of the creating of knowledge bases. But once we create this knowledge base, we will utilize the same knowledge base throughout the workshops that we are going to do further. So the collection is created successfully. I would highly encourage that if you are planning to do these testings at personal level, you can actually utilize documents that you would have at your end and try to ask RAG questions which were related to those documents. That would give you a more personalized answer and you would be able to relate to that information and see that whether you are getting the relevant accuracy with it or not. So for today's session, we will be using this synthetic data set, and we talked about specifically a document that you would see in this data set is this Octang Financial 10K. It's a PDF document which contains, and you can open it up and see that what information this document contains. It contains the financial information for a entity called as Octang. It's a financial document for that organization which contains that what all assets this organization have, in which year, how much cash equivalent data that they will have. So we are going to use this information. This will automatically be pulled up while we are using this RAG. So you will see questions related in this workshop, primarily related to Octang. Let's now go back and come to RAG concepts. So you see that finally we are at a stage where we are creating a knowledge base. Now finally our knowledge base, let's see if this command is completed. Yes, the command is completed, which means that our knowledge base is created. Now, one way is that you will see all this information over here that, okay, how my knowledge base is created. And the most important part of it is the knowledge base ID that you will see it over here. But if for some reason you are not able to find the knowledge base ID over here, you can always go back to the console in the same login session that you are at and just refresh the knowledge bases page. You will see that there is a new knowledge base created. There you go. We see that a new knowledge base is created. You click on that knowledge base and you will be able to find the knowledge base ID over here as well. And this is the most important part. Why? Because you are going to heavily use this knowledge base ID in the next sessions, in the next labs that we are going to do in today's session. So now let's come back and let's come back to our Jupyter notebook. Finally, this part is done. The next part is, like we earlier discussed about, uploading these documents. So You see that in synthetic data set, we had multiple documents and this have been uploaded to the bucket. Now, remember the flow that I explained earlier, that you have a data storage, everything is stored in S3 bucket first, and then from that bucket, we start a ingestion job which will pick up those documents, create chunks of it, and then send it to your vector DB. So don't get confused that if we have already uploaded the document, what are we ingesting here? We have uploaded the document only in S3. That's a simple object upload that we have done. But for the AI model to understand, I need to do the ingestion of all these documents, basically pre-process it, extract the text, chunk it, and then send it to the vector database. So that is what we are going to do it in the next step. There is a sleep time that you would see for 30 seconds that I've mentioned, so that all the roles that we have created earlier takes a minute to be in effect. You should not upload your personal doc on this lab session. I can see a question on chat. It's recommended only if you are doing this on your own AWS instance. Then only you should utilize it. Otherwise, it's recommended that you should use the data which is provided as part of the lab itself, because doing things beyond the scope of the lab might actually wipe the session that you would have created. All right, so you see that a job has started successfully for ingestion, and you can also see this job on the Amazon knowledge base. So you see that in the knowledge base, we have there is a data source that was created. Now, again, you have a S3 bucket and you have your vector database, and you vector database is basically nothing but your knowledge base that you are using. Now in this case, in between this, there is a bridge that needs to be built, and that bridge is called as data source. Data source is that bridge which tells your knowledge base that from this source you need to pick up that data, and this is my S3 bucket. So as a data source, I'm telling knowledge base that this is your data source, this is your S3 bucket. You continue to pick the data from this data source. Now, let's say that I am putting 5 files in my S3 bucket, and if I have to update that data, I have to add 2 more files to it in my S3 bucket. Will my knowledge base automatically pick up those 2 files? Answer is no. You have to continuously sync it, or as and when needed, you have to sync your data source, which is S3, with the knowledge base. All right, so now you can go to the data source and see that if any sync that happened. So the answer is that yes, the sync has happened. You can see that there are 7 files that it was able to understand and pick up. 5 files got uploaded successfully, 2 are failed. Don't worry about these 2 failed files, because it was simply about that the format was not supported of those files. And those were video files which we will later use in the lab. So for this one, it was able to pick up all the 5 text-based documents which we have created, which is notice, license, checkpoint, and the financial information and README. So that works us for this lab. Now let's go back and see. You would see the message that your job started successfully and it also completed. Now my job is completed successfully. I will store my knowledge base ID in a particular variable. You need to focus on this step importantly, because this is the step where you will start every other labs that we are going to do forward, because all the previous steps you don't have to redo it again. Now this is my knowledge base ID which has been picked up. Now finally it's time. Finally it's the action time. We have built so much. We have built the open search service collection. We have built the knowledge base. We have uploaded the documents to S3. We have built the data source, that bridge. Now my entire pipeline is ready to be tested with that knowledge base. So what I'm going to do it is I'll put a sample question that provide a summary of consolidated statements of cash flows of Octane Financial for this fiscal year, which is ending at December 31st, 2019. Now, focus on this question specifically. Why? Because this is not a question which you can ask any LLM model in general. They will not, they might not have the context of it, that, okay, what is Octane Financial? or how should I know about this information? But in this particular case, it will know that information because we have provided that context. And that is where the RAG plays a role, because it will be able to give me the answer because it has that context, it has all those documents which are required to answer this question. So let's run this. This is my query. And if you look at it, I have just put the same information in a query field. I'm passing this query over here as a text input to my LLM model. And here I'm using an Anthropic Cloud 3 model, but you can use other models which are supported by this lab. Now, finally, I run this query. It will give me print the output. So if you see that, it clearly tells me that according to the consolidated statements of cash flows in the fiscal year this, net cash provided is 710 million, net cash use is 240, and net cash provided is 350. Now, how this LLM model is able to get this information? Not that this LLM model was trained upon this information. The answer is very simple. We have given this LLM model a additional helper, which is our RAG, which provides this context to the model so that it is able to get that question and answer, able to get that answer from the context that we have shared. So primarily, this is how it works. If you look at it, you use a particular model, you do this, you run a query, and then you get a response. Now, there is another way. If you want an extra layer of control on this thing, you want to say that, okay, I want to only retrieve the response and not run this model directly in a single call. Basically, we are breaking down two steps here. One is whenever we are running a query, it first goes to my vector DB, gets the information, relevant information, which we called it as chunks. It gets all the chunks, pass it on to the LLM model so that LLM model can answer accurately. But in this case, what I'm doing it is I'm only getting the chunks and not passing on to the LLM model directly. I just want to see that what are those chunks which this Bedrock agent is able to get. So let's use that. And the query could be anything. You can keep the same query or you can run different queries. I would highly recommend try experimenting with the query part, change the text, go through that document, the Octane financial document, and you try to build any questions that you might have. Maybe also try to ask questions which are not relevant to this document itself. All right. Let's try this particular part and see what are the chunks that we have got. Now you see that with this code, you would be able to see what chunks were actually fetched to get that information. Now, I hope you folks are familiar with the chunks and chunking strategies. And on the chat, I see there is a question related to chunking strategies. There is a entire lab that we are going to do today to talk about the chunking strategies, which is hierarchical, semantic, or whether we don't want to use or a custom one. So we'll talk about it and we'll do the live example of those as well. But for the moment, in the easiest language, if you want to understand what are chunks, understand that we have a database where we have all this information. Just a second. So understand this, we have a database where we have stored all the information. Now, my Bedrock client agent will go with a query that, okay, I have this question. And before it goes with the query, it will break down those questions in the words and embeddings that is needed, because my vector DB only understands embeddings. It will not understand plain English. Using those embeddings, it will try to match whatever chunks that are there in the database. So you remember earlier, when we put all the data into vector DB, it just does not store it in a flat way. It creates small chunks out of it. And every chunk will have some relevance to what I am asking. Now, when I'm asking a question, which was my query here, let's say that I have 200 chunks in my vector DB, but only 10 chunks have that information which are relevant to my query that I'm asking. So of course, I will only fetching those chunks which are relevant to my query. And if you look at it in this code, what we are doing it is we are saying that whenever you're going to this, whenever you're doing this retrieval, and going to this doing this vector search, get me only the most five relevant results. The number of results I want to see is five. So at the bottom, if you see that the data that it has pulled out from the vector DB, you will see five chunks. You will also see from where this chunk is located. This chunk was part of this particular document, checkpoint document. Now, your chunks not necessarily has to be part from the same document, and that's the beauty, because you are not running it on one document, you're running it on entire vector DB. So the chunks could be from multiple documents or multiple sources. So if you look at it, your chunk one information is coming from checkpoint.pdf, but your chunk 2 information is coming from 10k pdf. And there is also a chunk score which tells you that how relevant this information was actually related to the query that you asked, so that the most relevant information will have the highest score. And by default you see that the score is sorted out in a descending order. So the score is 0 to 1, which means that you have to measure it everything in a decimal value. All right, now let's see that this is your chunk one, which have score of 3705873. Both chunks have a similar score because they are similarly relevant to this information. But like you go at the bottom, your chunk 3 and chunk 4, they will have different scores and decreasing scores because they are less relevant. Now I can always go and modify that. Okay, and why this chunk is important is that because let's say that I am asking a question which for which the answer is stored in 10 or 12 chunks, but I am asking this client or agent runtime to only retrieve 5 chunks, then my model itself would be able to build the answer only based on the information which is present in those 5 chunks. So that really we have to fine tune it in future. Whenever you are building such knowledge bases or models, you have to keep on trying that whether you are meeting that accuracy or not, because you don't want to miss out that information. Let's say I asked about a financial statement for 2025, and that information is present in 7 chunks, but my configuration tells me to pull out only 5 chunks. So I'll pick the 5 topmost relevant chunks and build the answer using that, which means that I might be missing out some critical information which might be relevant in those remaining 2 chunks. So based on my organization needs and see the patterns that okay, how much chunking is enough, how much retrieval that you need, you can fine tune these parameters in the production environment. Now we have understood that what is a chunk and how we get that. As part of this lab, there is also a cleanup section that is mentioned. Don't run this cleanup right away because we are going to reuse a lot of time. There was a question on chat that how we can do things quickly. The shortest answer is do the cleanup at the end of this entire workshop that you do, so that we can reuse a lot of this information that we have created here. So we have now learned about how RAG works. Let's now see that how retrieve and generate API works. Now we learned about that using a client runtime, you can make those calls, you can get the answers. But then there is a retrieve and generate API, which is a fully managed RAG. It's a fully managed service for you. It's one API that does all the things for you, both retrieval and generation of the answer. So we will see that, and also it will allow you to control the maximum number of results, do custom prompting, define how many chunks that you want to receive, which we saw a bit of it in the previous lab that we did. Now, we are going to use this retrieve and generate API in this second lab and see how that works and how this brings any results. Now, for this second lab, like I said in the previous lab, we have already installed the requirements, so you don't have to go through this step again. This saves a lot of time. And you have also restarted the kernel. You don't even have to do this part as well. So you can skip this part and come to the section where we are simply initializing the Boto session. Now, in this case, you will see that what is my Bedrock configuration, what is my Bedrock agent line that I'm using. By default, there is a certain model that will be used, but in this case, I'm defining that Anthropic Claude 3 Haiku model will be used in this case, which is one of the foundation models that I can use with Bedrock. So I set up these variables. Now, this is the part which I was speaking about in the previous lab, if you would see that. Let's, we don't have to do this manually. I would simply suggest that you go back to the previous lab and pick up the information that you have defined over here in a variable. After the knowledge base was created, you stored it in a file. There you go. This is the one. So the simple idea here is that we are not going to recreate this entire thing. Uh, we will just simply use that KBID over here. I'm sorry. What you need to do it is that you already know the KBID, which is knowledge base ID that you would have. Pick up the knowledge base ID from here. You can also pick it up from the lab code as well. I prefer doing it from the UI. Let's come back. Let's fill this variable information. Now let's run this one to store it. And finally, your KBID is stored. Now, what we are going to do it is, next we are going to do the same thing that we did earlier, but with a bit of difference. Now, there are two things that we are going to focus in this lab is how you control the maximum number of results and what role that it plays when you are asking a question. And the second is what is custom prompting. So if you remember the image that I shared earlier while explaining that in custom prompting, you are asking the FM model, your foundation model, to behave in a certain way, like behave like a civil engineer and then answer this question, so that it will take on that persona and try to answer your question using that persona. That is what we are going to see live over here. Let's do that. So if you see that, I'm going to build my prompt and that is going to my default prompt. Okay. So there are sections to it as well. What I'm saying it is that you are a question answering agent and I'll provide you with a set of search results. The user will provide you with a question. Your job is to answer the question using only the information that is there in the context retrieval or vector DB that you would have from the search results. If the search results do not contain that information that can answer, please state that you could not find an exact answer. So these are basically nothing but just instructions that I'm giving to my LLM model to behave in a certain way. And finally, within that prompt itself, I will fill up a variable which is search results, which is the same chunking data that I would pull out, give the output format instructions that, okay, how do you need to give the answer? What would be your formatting instructions? Now, let's first run this particular part. And finally, you look at it that we are using this retrieve and generate API call. We are making calling this via function. And all these things that we are going to call, creating these knowledge bases, calling all these functions. We are defining a function over here. But if there is any function which is calling a knowledge base or anything like that, you would want to learn that how those functions are created, what it is calling up internally. There was a question on chat as well that what are the models that can be used what with this by default. So I would highly recommend that you go to the utils section of the code that we downloaded, and you will see that there are a lot of Python files that are created for you, and we are utilizing those files to automatically create the knowledge base and everything. So if you click on this knowledge base, you will see that what are the valid generation models that we can use, what are the ranking models, re-ranking models, or embedding models. So all those questions will be answered over here, and it is the same steps that we followed. If you remember that we were creating the S3 bucket, we were creating a knowledge base, and then finally the OSS collection. So from where all these functions were called, it was from this file. So go through all these sources if you want to learn more in-depth details about what models that you are calling and what is the default configuration that we have given it over here, because there are common questions that would come across to your mind that, okay, I'm making a call to LLM, I'm doing chunking, what is the default chunking strategy if I don't define it, what is the token limit that I have defined over here. All these answers you will find it in these documents under utils. Now let's come back. to the rack concepts. All right. Okay, now let's define this function. So we have defined our default prompt over here. Let's define the function which will be calling this prompt. Now let's go through this function and first of all understand few key aspects of it. You will see a lot of functions very similar to each other, only minor tweaks that we are doing to making you learn that okay, what we are doing bit differently over here. For example, in this case, you see that the number of results are actually coming from max results, and this max result value is being passed upon as a constructor variable to this function, and we are saying that we want to get 5 max results, and there is a prompt template that will also be passed. Now this prompt template will go over here. So, and knowledge base id, you are already aware that we picked up that knowledge base id, stored it at a variable, and it will be using the same knowledge base id. So we are not creating the knowledge bases again. Then, so this has been defined in two functions. One is retrieve and generate. The other is print those generation results. So one is go back to the vector database, find the chunks, go to the LLM model, get the response, and finally do the generation of all those things. And once that has been generated, how do you actually present it? For that, we have defined another function, which is print generation results. Now, once you have defined both these functions, finally it's time for the action where you actually test it out and say that okay, provide a list of risk for Octabank Financial in number list without any description. I will be calling one function which is retrieve and generate, providing all those providing my query, and this is my query that I'm providing: kbid, model number, model arn, which is either Claude Haiku or something which we have already defined over here. Let's quickly go back and see that where you have defined the model. So previously we have defined all this information. Sorry, but yeah, there you go. You have the model model ID, and based on the model ID, I'm building the model ARN. And this has been passed upon this variable finally over here. There are two other values that are there. I'll tell you. One is your max results that has a default value of 5. So we are not passing that. We are going to use on those 5 results as well for now. And then we'll try to augment it and see what happens when we change it. So quick time, action time. Let's check how this works. So you see that my model has generated results, and it has print those results in the format that I was expecting it to present. First, telling me that this was your question and this is the answer to your question. I asked it to list out all the risk for this Octang Financial in a numbered list. So it's a numbered list. It does not have any description. It is only title based list that I have. Now, I would suggest that don't get confused between, for people who are quite new to the AI models or and these things. When we say number of results, if you remember, we mentioned max results as 5. Don't get confused that because we mentioned 5 results, we are getting only 5 answers here, 5 responses. This 5 is not related to that 5. Okay, and this gets very interesting because the 5 that we mentioned earlier was simply about chunking. How many chunks of data that you need to pull out from a vector DB. Now, within those 5 chunks, you can actually get answers for 6 or 7 or 8 bullet list. But in this case, it's just a coincidence you are getting it for 5. Now, how about I just change it for just for testing purposes and see that if I am trying to say that, okay, don't just pull 5 chunks, do it with the 8 chunks. And then I define it again, and then I run my query again. Now you see that I'm not getting 8 results, I'm getting 7 results. Though I mentioned 8, because this 7 has nothing to do with that 8. It simply means that it went to the database, got 8 chunks out of that database, and within those 8 chunks of information, it was only able to find 7 risks that were there. So what information that is coming up on screen, it depends that how many chunks that you are pulling it out. Now, it will also give you the retrieved context. It will be coming it in a single paragraph. But to be honest, once you break it down, it depends on the number of chunks that you are actually pulling it. Every chunk will finish something like this with a space over here. and you will see that a lot of chunks are actually being pulled out. If I reduce the number of max results, this retrieve context information is also gets reduced, and my results also gets reduced. For example, if I say that don't pull out with 8 chunks, I drastically reduce it to say that just do it with 1 chunk. So that's an interesting question. Somebody is asking on chat that how do we identify how many chunks we need to use? And that is where fine tuning strategies comes into the picture. Because see, you will have your own data, you understand your data, you understand the questions that your users will be asking. There is a training process that every of these models or applications, AI applications that you will build will go through. And during those training models or testing or validation, there are multiple parameters that you will tune to ensure that you are getting the right outcome. So let's say that you want to get an information something related to previous example, I'll take it like leave. All right. Now your company stores leave information in 10 documents, 10 different documents, 10 different types of leaves your company gives, like casual leave, annual leave, sick leave, and all that information is not in a single document. It's in 10 different documents, and you have created multiple chunks for those. Of course, you will be creating multiple chunks for those documents. Let's say that 20 chunks are created. Not 10 documents does not mean that you will create only 10 chunks. We'll learn more about it in the next lab on this one, where we go to the optimized one. So let's assume that for those 10 documents you have created 20 chunks, and your information still does not exist in those your information exists on those 20 chunks, and you are running a query. You get all that information, all types of leads. You reduce the number of chunks. You say that I want to get only 3 chunks, which means that whenever you're asking a question, how many types of leaves exist in my organization, your LLM model say that okay, only 3 types of leaves exist. Why? Because it never got the complete context from all the chunks that are needed. Because I filtered it to say that use only top 3 chunks, don't use all the chunks or 20 chunks. So you need to continue seeing whether your answers are accurate, whether they are getting enough chunks or not. So that way you need to tune it. There is no one stick fits all answer to it, to this question, because it will depend on the question, the type of industry, the type of document that you are dealing with, the information that you are dealing with. All right. I hope this answers. But coming back to this one, so now if you look at it, I reduce it to 1, which means that I only got 1 chunk, and out of this 1 chunk, my LLM model was able to find out only 3 risks. That does not mean that there are other risks that does not exist. It exists, but just because I'm limiting my model to work only on the topmost chunk, that is 1 chunk, so my answer would also be limited. And that comes back to the same thing, that I need to fine tune it so that it covers all those responses. So that's primarily the part of chunking and how this managed retrieval API. What we were learning about this one is using the retrieve and generate API. Yes, it will have, to answer it, it will have the cost and the tokens. Yes, it will have impact on everything that you do. It will also have an impact on the time. But the most important, more than the cost and tokens, the time it takes to run that query, the fast answer that you want to give. The less number of chunks, easier to process it. But again, it's a trade-off. Now, finally coming to the streaming response with generate retrieve and generate API. What we did earlier in the previous set of code is that we utilized this API, but it was giving the answer only once the complete answer is built out internally. So you would see a lot of LLM models. I'll not take the names. When they launched into the market, when you used to ask them a question, it used to give the entire answer in one go. It could take the model 3 seconds, 5 seconds, or even 10 seconds. But until and unless the model internally have that complete answer built out, it will not show it on the screen. And once it is done, it used to show all the information in one go. But there is a better way to deal with this. How do you stream that response as it is being built out? rather than waiting for it to completely build out. That is where you use retrieve and generate in a streaming method. Same thing, we are not doing anything different here except this part, which is retrieve and generate stream. But for this to work efficiently and for me to show this efficiently, I will increase this to 15 so that the information actually is getting pulled out and we are seeing it coming on screen. And you see that what we are doing it is we are running it in a loop to say that as soon as you are getting that information, just every chunk, just write it, keep on flashing it to the screen. So let's do that. Let's try this part as well. You see that I'm getting the list. I still haven't got the context. Oh, sorry. I think there is one part that was missed, which was printing these results. So let's also get the chunks of it, because otherwise we'll not be able to, because any of the models are quite fast. So what you do it is, in this particular same code block that you're running, just add this part. Why am I adding this part? Because this part gives me the chunking information. This tells me that what were the chunks that were actually used. So let's run this again. And you see that it is printing step by step. Did you notice that it was quite fast, but did you notice that it was printing step by step? Whatever information that was being retrieved, it will just go ahead and print it, rather than waiting for the entire model to build that answer and then share it. I'll try to run it again, and if you are able to notice that streaming that happens, it happens in fractions of second. So when you are doing the lab, you will notice that there is a slight difference, that it starts the answer within chunks. Okay, all right. And I think we have already covered this part, because I did not want to wait for the last part because it was important. So we already covered that by modifying that, how it impacts. Whether you want a comprehensive response, then you can increase the number of results so that your model gets more and more context. But if you want to just get the answer much quickly and faster, maybe it's not that accurate, maybe it does not have complete context, maybe it's not a comprehensive answer, then yeah, you can actually reduce the max results. So I can try this one as well, but I think we have already done that live in the previous one. So if you do it with three results, three chunks, in three chunks it gets five risk. But the same thing, if you get it in 10 chunks, it would get different list. It would get at least like 10 strategies. So we already did this chunking. Now let's move back. Let's move to the next step, which is the custom prompting feature, which is quite interesting because we learned about that. What happens when you ask your agent to behave in a certain way? So we already learned about this prompt. The only thing that we are going to different in this particular prompt to do it is that we are telling the agent to answer it in German. We are sorry we are asking the agent to answer it in German language unless asked otherwise. So even if I'm asking a question in English or any other language for that matter, it will still answer me in German until and unless I ask it that, okay, I don't want an answer in German. So let's say that I'm using the same query, same everything, just adding one statement to hear it and see how my agent actually behaves. And let's do this. And the question is same, by the way. The query was same, that I want to get the 10 list. I want to get the numbered list of risk that are associated with this Octane Financial. Now you see that my response is exactly same, which I was getting, but the only change is it is giving out to me in German. So I did not use any fancy technologies or tools to achieve this. Only thing I did it is ask my model to behave in a certain way. And that is what prompt engineering is. That rather than finding a different tool or something, just always check that whether your model is capable of that or not. So the second is that I can say that, let's say that you're building a RAG application, and uh, whatever query that is being asked, you want to use that output and feed that output in some other tool. Okay, that could also be possible. In that case, what you will do it is that you will ask that, okay, I want a JSON output of the same thing that you are answering. So I'm going to run the same query, but this time not a German answer, but in a JSON format. So you see that it has built the same information, but in JSON format. Okay. So I hope this helps. This tells you basics of how we learned about how we covered how what one API does. You can use the retrieve and generate API in this case, and what max results, and how you can control the chunking part, fetch as much as context as needed or as less context as needed. So let's move on to the next lab. And again, in this lab, remember, it tells you that remember to delete everything. Wait for it. Do not delete it as of now. Only once you are done it, because we are going to reuse all of that information in this case. Now, in the previous lab, in module 1, lab 2, we learned about retrieve and generate API, but there is a separate API, retrieve API. And as the name suggests that it's primarily about only the retrieval part. It does not generate the answer for you. So which means that if you want to get more control of it, you want to say that I only want to get the context from my vector DB, but I don't want to use this model. I want to do something else with that context. Maybe I have a separate application which will use that context to do some other work. In that case as well, you will use only the retrieve API. Same work, but we are doing it in a only retrieve fashion. So let's see how that works on ground. And again, I'm going to use the same KB, same knowledge base that I have in the previous labs. Just a moment. All right. Where is the KB? There you go. That is my KB. And finally, I put it and then I run it. So it stores my KB. And then same basic steps which we are going to do: initiate our Bedrock client so that we are able to interact with our environment, and we do basic checks like printing the region or printing the account ID so that we know that we are into the right session and it is able to make that connection and fetch that information before we decide that okay, my API is failing or something like that. Now, let's look at this part. I am sure that you would already be now by this stage with all the explanation that we have discussed. You would already know what this is, but let's quickly cover this part as well. What this is. So the first flow that we understood was about how RAG plays a role. All right. If you in this one, if you look at it, what I want to do it is over here is that you have a customized RAG flow. In this case, your user is giving a query on top, and that query is going to the prompt generation, prompt augmentation, where you are building up your prompt. But before you build up your prompt, at the same time, it does an retrieve API call. Retrieve API call goes back to your embedding vector databases, which is your knowledge base. At the bottom, what you see is your knowledge base, Amazon Bedrock knowledge base, where all your embeddings for your documents are stored so that it is able to get the context out of it. Remember all those chunks that we were seeing? That is the context. That is what it gets out of it. And finally, we pass on that context to prompt augmentation so that it merges your query with the query that user has asked, merged it with the context, and finally pass on both the things to the large language model and generate a response for it. Now, in this case, we are not generating the response directly, we are depending on the LLM model. So in case if you want to get more control out of it. All right, let's now see that how this works live. Okay, I need to increase it again. It's too much. All right, let's see how this works on ground. Same thing that we are doing. We are defining a function for the retrieve. Uh, Number of results will be keeping it 5. Initialize your knowledge base, and then focus it on here that we are saying that what was the total operating lease liability and total sublease income of the octane. The same questions, different question, but for the same entity that we are asking. Now in this case, let's run this query and see that what it is able to pick out. So I said that do only the five results, and it is able to get the context, it is able to get the location, metadata from where it is picking it up, and it is also giving me the score. We learned about the score, that score tells us how relevant this chunk is to the question that I'm asking, and it will give you the topmost relevant chunks. So the more you go or scroll at the bottom, your score should decrease or otherwise should remain the same. That's how it goes. So it is able to finally give you all that chunk. Now focus on one part. In this entire code base, we are not responding to the end user for their query. We are not doing that. We are only getting the context, so that we can utilize this context later on with the next set of code. So what we have done it is that in previous lab, we were doing both the things with one call, which is retrieve and generate. In this case, you are only doing the retrieval. So now from the context, from this retrieval, I want to fetch the context. I've built this function to fetch the context. When I say context, I'm just picking up the content and text. I don't care about this score or metadata that is there, because by default I'll get all the things. But to use that information, for me, the useful information is only the text part, which is within the content. And let's do that and see that whether I'm getting the context for it. See, I have got the same information now in the textual format without the metadata or scoring that is there. Now what I'm going to do it is within my prompt. Now why this is a bit different from the previous thing is, again and again I'm explaining that in this case what you are doing it is you are providing this context manually, and that makes a big difference, because in the previous retrieve and generate API you can pass on the context, but here you are passing on the context as part of your prompt, so that you get complete control of it. If you want to modify that context or do some changes to the context before you actually pass it on to the model. So you are passing it on as a variable to your prompt. Variable is same. You are defining and saying that you are a financial advisor AI system, and that provides answers to questions by using fact base and information that is stored in your vector DB or uh, whichever database that you are using in this case. And we are also saying that if you don't know the answer, just say that you don't know and don't try to make up an answer. Try to use different questions as well. In one of the coming labs we are going to do soon, I'll try to show you that how the model will actually behave uh, if if a question which is not within the context boundaries you are asking. So we'll see that as well. Now let's define this prompt. Okay, and we have defined it. Finally we make the invocation, and yeah, in this case we see that payload with model parameters. Now this is what that gives you a lot more control on things here, because you are now making your own call and you decide that okay, how many max tokens you want to process, what is the temperature and top P. I hope you folks have the idea about the top K, top P, and the temperature, because it is directly related to the fine tuning of the model that you do. If your model is hallucinating too much, it is giving made up answers too much, maybe you need to look at the temperature. So as of now, for the purpose of this lab, I'll keep the same values, and I'm defining that I'm using Anthropic Cloud 3 Haiku model. You can change this to use a different version from the model. Supported models I have shown you previously. Now let's do this and let's print it. Now, when you run it and you go through the answer, read it very carefully, because it exactly tells you that the question that we asked. Let's go back to the question quickly and read this question. What was the query? The query was, we want to know the financial status as of 2022. Okay. Now, the context that I have provided, my knowledge base, whatever documents that are there in my knowledge base, contains data only up till 2021. And I'm asking a question about 2022. So how does my model behave? What my model response in this case is that you will see that I know some part of it, but the context only provides information about Octane's portfolio up till 2021. I don't have any information about 2022. Therefore, I do not know the answer to this question. Now, this is important. Why? Because this helps me understand that how can I limit the responses? How can I ask my model to only get the responses from the context and do not hallucinate or start making up answers as and when needed? So that is where the RAG plays a big role. I hope this helps you. And then there's a LangChain integration. That's an additional part to this workshop. We will be, in the interest of time, considering we are already almost like 1.5 hours into this workshop and we still have a lot of topics to cover. I will not go through and run this entire thing, but this helps you. Whether there were some questions that were asked on chat, that how you do the retrieval, or whether you want to, which approach that you want to use, hybrid, semantic, you can configure this over here. If you want to build your own LangChain pipeline, then how do you do this, how you use these APIs? Feel free to go ahead and run these things, same things, but in a different and more controlled environment that you want to do. Okay, so in the interest of time, let's cover this part as well. Let's learn about RAGAS, which is RAG assessment framework that we have. And this, I personally, I love this topic because a lot of times we have learned about, okay, I can ask a question, the information is available in knowledge base, I'm able to pull out these information, and the answer is being provided to the user. But how accurate that answer was, how can I evaluate the responses that were given to the user, whether those were relevant enough, coherent enough, they were like or whether they contained any harmful or malicious content, how correct it was in terms of the actual answer which I was expecting. So in those cases, think of it like in a very, very simple terms, not exactly, but in simple terms, it's like a monitoring tool which gives you and tells you that how will you assess it based on certain parameters, how my responses were. So RAG assessment framework, this will help you do that. Let's learn this. I'll not go through this theoretical part of it. The flow remains the same. We have seen this flow. We are going to use the same knowledge base. The only thing that we are going to do differently is we'll use Vagas, which will tell us which will tell us the scores for faithfulness, context recall, context entities recall, or precision, even the basics of it. It will be able to give us all these information with this framework. Now let's take a use case, and we are going to use the same use case, which is Octane Financial 10K reports. Okay, same environment, we're not changing anything, we are going to use the same knowledge base ID. And finally, what we are going to do it is we are going to import the required packages, use Anthropic Cloud 3, and let's run this one. And yep, just a minute. Okay, I'm not going to install this again or restart this. I will simply skip these steps and just provide my knowledge base ID. I will pick it up. That's why I said it's important. We will use this in all the upcoming one wherever it is needed. So let's do that. And let's run it. Same routine activity. We are going to initiate the Bedrock client. We are going to ensure that we are into the right region and right account. Make sure that you get the account number same always in all the notebook or labs that you're running. All right. Let's do it now. So now in this one, what we are doing it is we are importing the required libraries. We are setting up setting up the context for what is going to be my model, which version of it. For text generation, if I want to use Anthropic, and for evaluation, both I want to use the same. I can use different if needed. But in this case, for both the purposes, I'm using the same model. So one is where my response is created, my text is generated, and then after the generation happens, after the response is available, then I evaluate that response, that how accurate it was. All right, let's see that. Retriever, it fetches everything that is there in the knowledge base. I will come to the most interesting part that you will see over here. This is a question that I'm going to use, provide a list of few ways. Same question, we did this in the previous one as well. But now this time, what we are going to do it is see the evaluation part as well. First, we run the data, say, just see that whether we are getting the right response or not. And then finally, we prepare the evaluation data. Now, what is evaluation data? Very quickly, I'll touch base upon this topic because whenever you are asking a question, your model is picking up the context and then generating the answer. You are asking the model to evaluate that answer, but you need to give something to compare it with. You need to tell the model that, okay, whatever response that you are giving, this, in my opinion, this is the right answer. This is your ground truth. We call it ground truth in this case, so that the model will compare that, okay, if this question was asked and this was supposed to be the right answer, and how the question was asked to me and how I answered it, it will compare both the situations and both the responses. One that was given as a ground truth to say that this is how it should have been, and this is what you answered. And comparing these two, it will evaluate and give all those metrics that is there. So what we are defining it over here is that if such questions are asked, I'm giving multiple questions because you cannot give just one part of it ground truth. And in a real production environment, to be honest, this is not this is quite small, but for the lab purposes we are just creating a ground truth for 5 questions and answers that are there. But in a production environment, you will have a lot of data that is there. And there is something that you will learn later on as well, not part of this workshop, but just an additional information. Usually companies also put a human feedback loop in between to say that whenever the response is there, you give a feedback. Often at today's LLM models that you interact with, you would see that there is a thumbs up or thumbs down icon. What it tells the model is that whether it was the right answer that I provided, accurate answer, I feel. The more feedback that we give, it use that feedback and adds it into the ground truth. So your ground truth continues to build and build, and it becomes more accurate over the time. But for this lab example, what I'm going to do it is we provide 5 questions and 5 correct answers as per us how it should be. And then we ask a question to this one and then compare it how it gives. So let's do that. It's creating that data set, importing it. Let's just wait. All right, so this ground truth part is done. Now the final and most important part, which is how do you evaluate your RAG application in terms of it. And you see that I'm defining that there are more than these parameters that you would see if you just do internet search. You will see that there are more than these parameters, and you can update these or reduce them, increase them as needed. But for this lab context, we are trying to get the details of these metrics and say that let's do this. And just ignore the warnings that you would get, because there are certain methods that we are these things are evaluating literally on a daily basis. So you will see that there are functions which are soon going to be deprecated or no longer available, but the newer version of those things are available, so you can safely ignore these things and not worry about it. Even at the end of this evaluation, you will see a statement saying that failed to load the result, but that is okay because we are printing the result separately, and we will learn about it that what my result is. But as of now, it is evaluating, and internally what it is doing, it it generated a response based on the query that I provided. It then compared that response from the ground truth information that I am sharing, and then finally gives the result to me. Let's just wait a few more seconds. Yeah. You see that, like I mentioned, that it will tell you that failed to pass the output. It does not mean that it was not able to generate the output. it was only failed to pass it, which means present it to the screen, which is fine because we have the next step which actually gives us that output. So this way you are actually processing this output. Now you see that in terms of faithfulness, we got a score, and every score that you will see again is based on 0 to 1 metric. So you see that faithfulness wise it was zero point 0.7, quite fine, quite a good number. And this comes back to one of the previous questions somebody was asking, that how do we fine tune these things? Now these are the things that will help you fine tune that, and especially points like coherence, correctness, consciousness, and maliciousness, harmfulness. These are very, very important that organizations in today's production world, I'm working with a lot of customers, they evaluate it based on these parameters. Because does it contain any harmful words or malicious information? No. The answer is no. It should not. So getting a zero value is a very good output that you would get. In a real world, it might be a bit different. You might not get exactly zero. If you are getting it, if you are able to achieve it, that's pretty good. And finally, the correctness in these things, consciousness, whether it was correct. There are certain things like context precision and context recall, and it directly ties up to the context that we pulled out. This will definitely have an impact based on the number of chunks that you are pulling in. So of course, if you are pulling in more and more chunks, you get more context precision that would be there. But again, it's everything is a trade-off. Not everything you can make the best, not everything you can achieve the highest. So for example, you can not achieve everything like 1.0 and 0. That's not practically possible. You can aim to achieve that and be get as closer as possible to it. So that's the approach. So finally, we learned about that. We want to print it in a in a tabular information. This command is more important because in this case, if you look at it, it is actually telling you that what information it compared with which information and what was the score on each parameter. So we knew that, okay, we are getting these scores, but how internally it compared each information. Like what part of the question, what was my actual question, what was my ground truth, and comparing both these things, what was my actual result for all these things. You see this? It compared my query with each ground truth that I provided. I provided 5 questions, if you remember. So I asked only one query. It will pick up that query, compare it with all the 5 ground truths that I provided, all the 5 responses in the ground truth. And there you get the score. So this basically helps you when you are working on the production environment. All right. I'll take a quick pause. Just give me a few seconds. All right. I think just one thing. All right, I think we have covered quite a good amount of information related to RAG, how it works, how different mechanisms that are work. Again, in the interest of time, unfortunately, I would not be able to cover this lab, but I let me give you the context of this lab when you're doing it, because primarily this lab is about using the document level API. uh, in a very simple term, and doing this won't take you much time because it is straightforward. It does not contain any tuning or anything. It is primarily about, you are, remember that we are putting all the documents in S3, then we are ingesting those documents into our vector DB and creating that knowledge basis. Why do I need S3? Simple answer is just to have a storage of the documents at first. But can I avoid S3? Can I not directly, considering my knowledge base is also a storage? My knowledge base anyhow will pick up all the documents and store it. It will chunk it. It will not store it as it is. It will chunk it and then store it. But can I not do it directly with knowledge base instead of going via the S3 path? The answer is yes, you can do it. And this is where your document level API comes into the picture. So in this example, what you will do it is you will go ahead and directly interact with your knowledge base. So there won't be any S3. What you're doing it is you are having a knowledge base. You are directly putting the data, interacting with the API, and just running it. Now you will see a lot of S3 related information in this one, because understand this part, whenever you are using S3 or not using S3 in this case, there would still be bit of S3, because you need how you call it, you need a bridge in between. Before the chunks are created, there is a layer in which it gets temporarily stored. So even when we previously created the buckets, there's a temporary bucket that gets created and you store it and then it gets chunked out. But at the end of the day, you are not directly doing it. So your data source will be S3 in this case, but you can directly use the DLA API. All right, let's move on to the next interesting part, which is the optimizing accuracy. And again, there are too many things that are in here. We have limited time, so I'll be able to cover the first part of this one, because that's the important one. Everything else is related to metadata generation, automatic metadata generation, or how you update the CSV metadata, customize it. That's you can go through that in your sweet time. Let's now begin with this one. So we learned a lot about chunking. Let's see that how chunking works internally, and how does it actually have an impact, and what chunking models or methods that we have available. And we are going to see all those in a live working environment. Let's do this. Where we begin with, we have done this, pip install, that's fine. Restart kernel, okay. We do the import. Let's do this. Let's restart the kernel, Bodo core. We are using the same Bodo version. Again, the same thing. We are importing the necessary libraries, setting up the current path where we are on, then initiating our Bedrock client. We are in the same account, using the same region. Absolutely fine. Then this is where I'm creating all the variables. I'm not creating any resource right now. I'm creating all the variables, that what would be the name of those variables, what suffix would be to it, and we are going to use different knowledge bases in this case. So this is going to be little bit time consuming, because we have to create different knowledge bases for different chunking strategies that we are using. So when we are creating a knowledge base, it asks us that what chunking strategy that you want to use. Now, if I have used a hierarchical chunking strategy on that knowledge base, I cannot change it right away. So what I'm going to do it is, as part of this lab, we are going to create different knowledge bases for each. So let's start with the first chunking strategy. By the way, just to let everyone know, before we start with the code running part and everything, just covering a few basics of chunking strategy that we learned about. So we learned that what is chunking? It simply means that whenever you are ingesting your data into a knowledge base, it breaks down that into small chunks. Now, what does define that, on what size it needs to break it down, or on what basis it needs to break it down? That is the chunking strategy that defines. Fixed size simply means that there is a fixed size, so every information will be broken down into equal size of chunks. That's as simple as it sounds. Now, of course, size you can define it internally based on whatever size that you want to choose. Again, you will have to fine tune it. You cannot keep it too big of a chunk or too small of a chunk. Everything has pros and cons, and all this gets covered in fine tuning. Now, none is where I don't want to define this particular part, and we'll cover that part as well. None is interesting one, because that allows you to do the custom one as well. Then we have hierarchical and semantic. Now, hierarchical, as the name sounds, and in a very simple layman language, I'll explain this part is, let's say you have a document. In a document, you have headings, and each heading has certain paragraph below that explaining that heading, probably that information. And usually we have all those documents, like even the document that we are currently seeing on screen. You see that this is my heading 2.1, upload the data set to S3, and then there is a certain description to it, like what this heading is all about and the entire explanation of it. Now, when I choose a hierarchical chunking strategy, what it does is that it treats the information in a parent and child relationship. It will treat, let's say that my parent chunk, and you will have multiple chunks. You will have parent chunks and child chunks, and this is very, again, an important aspect of AI, because when we are doing the search, we do the search on child chunks, but the answer will be coming in from parent chunks. We'll learn more about this in a following one, probably in this one or maybe the next one that is there. But for the moment, understand this: in chunking, you will tell that if my chunking strategy is hierarchical, then in that case, it will be simply based on a structure of that document, how that structure has been defined. And considering it's my document, it's my own data set that I'm uploading and using it for these AI models, I will know that what structure that my document is, which structure that needs to be picked up as a parent, and which structure that needs to be picked up as the data point. And the model automatically does that for you. Now, in this case, and the last one is semantic. In semantic, it is purely based on the meaning. And in both hierarchical and semantic, your chunk sizes will not be equal to each other. It will be completely based on the information that is related to the child, information that is related to parents, or in case of semantic, it is based on a meaning. So let's say I have a document. The first two paragraphs of the document talks about medical field, and the last five paragraph talks about civil engineering field. Now, if I go with semantic, semantic will put up one chunk of my medical field with two paragraphs, and last five paragraphs into one, because the meaning is different. It does the chunking based on the meaning relevancy of the content that is there, not simply based on a fixed size, or not simply defining on the title or header, because it could be possible that in a single document you have 10 titles, but all 10 are not related to each other. Out of those, 5 titles are related to each other, then 3, then 2. So again, which strategy to pick, it totally depends on your use case. It totally depends that what information that you are working on, and you will get to know the answer when you start using these models and using these strategies. So for this workshop, what we'll do it is we will learn from that. We'll try to see that how this makes a difference and what are different strategies. So let's do that live. Enough of uh, talking on this one, because this also takes certain bit of time. Because in this workshop specifically, we are going to create a knowledge base, and creating knowledge base is a bit time consuming process, because internally it calls a lot of other services. OSS creates OSS collection, creating roles and everything is pretty easy, straightforward. But knowledge bases, it takes time. Meanwhile, while this is happening, because I know it's gonna take some time, it will take some time. Let me put up a. This is going on. Let me put up a question over here. If That's our first question. So if you are on chat or on oh, where did that go? Okay, if you are on chat or comment, there are no prizes. There are no wrong answers to it. But if you know the answer, I would love that if you are able to put it on the chat here. Sorry, this got disappeared. Yep. So the question is about your knowledge base just finished ingestion, which we seen it live. What superpower did it gain at the moment? Does it allow you to auto scale EC2? It allows you to understand your documents through embeddings, or ability to store videos, ability to monitor cloud watch logs. Okay, I see the answers are coming in. Absolutely, all of you are pretty good and correct. Good to know that we are focusing on this one. Are you up for the second question as well while the knowledge bases are getting created? All right. So let's do the second one. You ask a knowledge, and by the way, first one, B is the correct answer. Everybody mentioned on the chat B. That's the correct answer. Question two, we are saying you ask a knowledge base a question and it gives an answer grounded in your documents. So which part of RAG just kicked in? Bit tricky, but yeah, if you're focusing, then yes, should know whether it is translate, ingest, generate, retrieve. Absolutely. So whoever said D, you all folks are absolutely correct. That's the right answer that is there. Good that we are learning that the retrieval part is what gets kicked in whenever we are actually doing the retrieval of those documents as soon as the query is raised. All right, we will do the questions later on. Let's see if our remaining questions will cover later on. Let's see that if that is created. Okay, this is done. So let's now upload all the files. Again, same files, we are picking it up from the synthetic data set and we are feeding it into our knowledge base. Let's start the ingestion job. And all these things you would actually see it for the folks who might have joined in late. I'll show that all these things that are happening on this code base on the lab, you will actually see it happening on the UI as well. So if I now go back to my knowledge bases, I'll see that I have two knowledge bases. One which I was using it from quite 1.5 hours because we have been reusing the same knowledge base. We were not creating it to save the resources and save time. But for this lab, we need to create a different one because there are different chunking strategies that we are using. So in this particular case, let's go back and see that. Uh, you see that it was all this was uploaded to this particular KB, all right, which is 2120910. And then if I go back and if I see this is the KB. So previously we have been using this KB a lot. I think now with the upcoming labs, we will be using different KBs. And if I go with that, go inside that, I see that there is a data source. It is available. It has already done that. And it has used a fixed chunking size text chunk, right? Which is the strategy that is being used over here. All right. Let's come back and pull out the knowledge base ID so that we can now test it out. By this time, I think all of you have been familiar with the process that every time we do something, we build a knowledge base and then we utilize that knowledge base as our RAG context. All right, let's test out this knowledge base. This is my query. Provide a summary of consolidated statements of cash flow for this Octank. Same query, which we have used earlier as well, but this time I'm asking for 2019 and see that what response do I get in this particular case. We need to wait for 20 seconds is a sleep timer and few seconds for the response to get generated. All right. It was not able to answer my query. No, that shouldn't have been the case. Am I using the right KB? Yeah, this is my KB. Let me try to run it again. Sometimes it happens because your KB gets updated in real time, and it might not have that, the API might not have all that information available right away, so it might take some minute. So if you see that response, just try running it once again. Oh, that's very strange because I'm not able to get response. Let's fix it on live. Uh, oh, I did. Oh, I missed this part. Yes, yes, you're absolutely right. It's no, it's not about storing the KB ID. We are storing the KB ID. Somebody asked on chat, we are storing the KB ID. The important part I missed was doing the ingestion. My documents are still in that, but the ingestion is still not done. So let's do it. Let's wait for a minute. Let's go back on the storage. I have the data source defined. You see that I have the data source defined. If you receive this error, another mistake which I made over here was I did not did the ingestion. Ingestion basically is if you are doing a sync, you still need to do a sync of this one. So you can do it through here as well, but yeah, doing it with the lab is much easier and simpler. So you see that the job one has started, and this is the data source ID. It is ignoring one or two files, that is fine, but it is getting most of the files, which still works for me. And I can validate this by actually going to my this page, knowledge KB, and do a refresh, because you see that earlier I was not seeing any sync job that was done. Now I do see that the sync was triggered, which means that finally my KB is synced with the data source. Now let's come back. All right. It's finally completed. The ingestion job is done. I am already storing my KB ID. And finally, it's time to test it out. All right. So there you go. There we are seeing all the information that is needed. We asked a query about 2019, and the KB, if you remember, it has that information for 2019. It did not have it for 2022, but it had it for 2019, and we are getting this response as expected. So far, this is working fine. But as part of this workshop, we were not trying to learn about what response we get or whether it was accurate or not. We were trying to learn about chunking strategy. So let's say that in this particular response, which was retrieved, what were the chunks that were used, what was their location, metadata, and remember that in this one we actually mentioned to give five number of results, and five results does not mean the results that you get on screen. It means the number of chunks that you're planning to pull or asking the model to pull. And finally, I see that every information that you will see, the number of citations used to generate the response are 5. You get every chunk from that information is pulled out. So far, we have been familiar with the process. And this was simply because we used a fixed chunking strategy. Now, you remember in the fixed strategy, every chunk will look almost equal. It's like it just have been divided in equal parts. It doesn't matter whether the information was completed or not, because even if you look at chunk 4, it was broken down somewhere in the middle of the sentence, because that's the chunk. We just asked it to divide it in equal part. And then finally, you would see that all these chunks are there. You would see the difference that it was simply splitted as in equal sizes, and you can try running this based on multiple, after changing multiple number of chunks as well. So we saw this example with retrieve and generate API. All right, we already talked about it. You Yeah, you see that we are testing this knowledge base based on two parts to it. One was testing it with retrieve and generate API, and then we already talked about using retrieve API only and not generating any response. That's the second part of it where you use this one. Test knowledge base with retrieve API only. Let's try this as well. Because in this case, we are not generating a response, we are just getting the chunks out of it. So it tells me that, okay, these were the 5 chunks, but we are not generating any response. We are just looking into the chunks. And always focus on the chunk score. All right. Now, let's go ahead and let's move to the third chunking strategy very quickly. Hierarchical. We discussed this about hierarchical. We learned this about it works on more like a nested data sets where you have a parent chunk, which is a much larger chunk, and then you have a child chunk, which is a smaller chunk but at a lower level. For example, in a parent chunk, you will have uh, headings and documents and sections, but in a smaller chunk you might have just paragraphs or sentences. Now, why this is helpful? Why would somebody actually use this kind of chunking method? That's the most important part, because it helps you with efficient retrieval and context preservation. Now, I'll if I take a layman example, let's say that I am in the previous example, what we did was we equally divided into fixed sizes. Like, I don't care what information is relevant to what context, just divided into equal chunks, and I will go and search through each chunk. Okay, but let's say I use hierarchical chunking. In that case, uh, 200 chunks are created from my document, and I'm just taking a example, random example. 200 chunks are created from my document. Out of those 200 chunks, 50 chunks are related to civil engineering topic. All right, and 100 chunks are related to medical life sciences topic, and all the other 50 chunks are randomly for different topics, like 3 or 4 or 5 topics. Now, what will happen is that whenever I put up a question, a query, the model will go, it will convert it into embedding, it will match that embedding, it it will go to all the, and sorry, I missed one part, that when you are getting those 200 chunks, you have 200 child chunks, and there are parent chunks as well for that. Now, parent chunks would be for those 50 that are related to civil engineering, you have a single parent chunk and 50 child chunks. Okay, I'll tell you why parent creating that parent chunk is useful, because what we are doing is that we are maintaining a relationship between relevant information within those 200 chunks. Now, whenever I put up a query, the model will go, the model will check uh, within child chunks, and as soon as it reaches the child chunk which is relevant to my query, it will see that what is the parent chunk of that child. I will know that, okay, for this chunk 23, the parent is civil engineering. And from there onwards, my model know that most of my information will actually be available in the chunks that are related to this parent chunk, because my topic, my query was about that topic. So this is what helps you in getting that context information much efficiently, because you are not going through each and every chunk. You will go through each and every chunk, but you will be able to find out the relevant chunks much faster because of this parent and child relationship that is there. And that is what we called as, it helps preserve that context. Now, on ground, when you do it, let's see how this looks. I should have started this because this takes a bit of time creating that knowledge base once again, because this time we are creating it based on the hierarchical chunking strategy. So meanwhile, this is getting created. Back to the quiz part. Let me see if we have covered those quiz questions or not. Those questions might be advanced in this case. Okay, I think this might be, will focusing on the next one. What should, no, I think, yeah, I think this should be relevant, because based on what we have heard so far. The question is about question number 5 that you see on the screen. When using fixed size chunking, how are documents typically split? Is it like based on semantic meaning? It's on equal size chunks by automatically detecting what is the heading, subheading, paragraph, or only when the model requests it? If you can just type in the answers. Okay. I see one person responded as C and most of us responded as B. The correct answer is B because C is not the right answer. The automatically detecting of headings is what is done in the semantic chunking, which is what we are going to learn after this hierarchical chunking. Sorry, in hierarchical chunking, it is done, not in semantic. Hierarchical chunking, it detects the headings and subheadings and all that, which we are doing it right now in this particular lab. So in fixed chunking, it's primarily about distributing it in equal sizes chunks with a fixed character or token length. And again, within the same files which we saw earlier, if you joined in bit early, you can go to the utils package and see that there are files which defines that what is the token limit that we are going to use in this case. In fact, why not, let's just, while this is being created, is it created? Let me see. No, it's still being created. So while this is being created, let's quickly go back. Let's go to utils and let's see that we are creating this one. I think it was in one of these files. Yeah, there you go. So if you see that whenever you are passing on these parameters, there's certain default configuration that goes behind the scenes. You can of course modify it and play around, not in the lab environment, but on the production environment, I would suggest that. But for your understanding, this is the limits that you actually give and say that, okay, divide it based on what is your chunking configuration, 300 tokens. So yeah, that's how it will divide. And for semantic and everything, you will find the configurations over here. It's knowledge underscore base py file. Let's come back. Let's see whether our knowledge base is yet created or not. It's created. Finally, it's done. And finally, this time we have created with hierarchical strategy. Let's also quickly validate in the knowledge base part. Where did we go? Bedrock knowledge base. Oh, sorry, knowledge base. Did I miss? Did I close that? Okay, I'll search it at knowledge bases. There we go. Oh, okay. You see that another knowledge base has been created, which is hierarchical one in nature. Don't go by the name, just open it up, check what is your data source strategy that is defined here, hierarchical chunking. Okay, let's now go and let's run this up. So our knowledge base is created. I'm going to run the ingestion, which is going to take another minute. And then finally, I'll save the KBID. Let's just give it a minute. I hope so far you have been able to find this session interesting and understand basic rack concepts, understand the chunking strategies. See, there are more advanced topics in this workshop. If you go to the other one, unfortunately, I don't think so with the time limitation that we have, we will not be able to cover everything, but you will have access to this entire lab and you will have access to all these topics that you can run and go through, and I would highly recommend to go through each one of them, though I'll try to cover as much as possible. But this entire lab is beyond few hours it takes. So go ahead, do not wait for the last minute, because this kind of lab you would not be able to do it within 1 hour or 2 hours. It takes a lot of time, it takes a lot of understanding to go through it, and each topic is important more than the previous one. But why I wanted to cover most of the basic sessions is because this builds your base for the rack. All right, okay, so save the knowledge base. This is completed. Let's test it out. Now we are testing it with the hierarchical configuration. Remember that. That's the only difference that is going to happen. We are running the same query. And then we'll see the hierarchical citations that are there. Right. This is still running. It's taking a few seconds. All right. Query is same. We have asked the same query, same response, but the new thing that we want to learn about is the hierarchical chunking over here. So how the chunks are there. Now, this is where it gets bit interesting because, like I mentioned earlier, and if you're looking at the chunks, you will see that there is only one chunk that has come out and it was able to get it. Why this chunk is so big and why we are getting only one chunk? Uh, and does it matter based on the number of results that we mentioned at five? We mentioned at five, which means that ideally there should be five chunks. Why we have only one chunk in the response? And this is where it gets interesting because I mentioned earlier, all your information gets divided into parent and child chunks. You have parent chunks and child chunks. All right. The query that you do, the retrieval part that you do, the information lookup that happens, it happens on the child chunks. But the response is generated using the parent chunk because parent chunk will anyhow contain all the information from the child chunk. There is a question when first time I was learning about these topics almost a year ago, it was about the first question came to mind, why am I repeating that information? The same information is in parent chunk, same information is in child chunk. Yes, it is repetitive. That information is repetitive. It will increase bit of storage as well, but it comes up with the biggest benefit, which is the efficient retrieval, much faster and efficient retrieval. So when you're trying it your own lab environments in anything, then go ahead and observe the time that it takes. And in a production environment, you will see that even a lag for a second has a cost to it. So that is where it is okay to spend little bit of the cost on the storage, but it is much more efficient retrieval. That is what matters here. So what you are seeing it as a response here is the parent chunk. Now the five chunks that we used was the child chunks, but you will see the parent chunks as a response. Internally, it will maintain that relationship between those parent chunks and child chunks. And that is what hierarchical uh, chunking strategy means. All right. Uh, this is the same one, but without the generate part. Again, every workshop has been given both the examples, which is one with retrieve and generate, and the other is only with retrieve API if you want to customize. So in the interest of time, I'll go ahead and move to the semantic one. Let's go because this also takes bit time. Let it create the semantic one. So meanwhile, it is creating it. How about we take another quiz time? Okay, so quiz time. What is the key idea behind hierarchical chunking? And we literally just saw a live example of hierarchical chunking and learned about it. Does it mean that we split everything into equal parts, or does it mean that we split the document in a structure like section heading, then break into smaller chunks, or we only create a big chunk, always overlap chunks by 50%? What exactly is the benefit? What is the key idea behind it that you do? Okay, I see responses coming in. Most of it says B. Let's see. I think I have this. And somebody says C as well. So the correct answer is B. C is not the correct answer. We are not doing this to create one big chunk. In this hierarchical ones, there will be parent chunks, which may seem like a big chunk and may seem true that you are only creating one chunk or one big chunk, because as a result you only get as a result you only get a parent chunk. That could be two or three parent chunks, but those two three parent chunks might have 20 30 or a number of child chunks. So the correct answer is B, where you first split the document by structure and then break it into smaller chunks. All right, let's come back and see this, whether it has reached some stage. Okay, it's still creating that knowledge base. Yes, exactly on chart. Same like headings in sections. That's true. Okay, let's see whether this is completed. Finally, a knowledge base is created. We go back, we validate the knowledge bases that we have. We already see the standard hierarchical. We should see a new one as well, which was for semantic. Uh, let's go to the semantic one, see the whether the data source has been defined, and the data source has been defined for semantic chunking. Now let's run the same usual exercise that we have. All right, let's go back. Uh, Oops, we still need to do the ingestion. I don't want to miss the ingestion once again, because then my model will not be able to get the context. Oops, I think. All right, so the job is started successfully. Let's go back and validate whether this job has been started. On the same data source, you would see a job is currently running. It is currently into syncing mode. So things are going fine with this one. We'll let the job complete and then we'll move to the testing part. And then the same testing part, we are doing exactly the same thing as asking the same query. The only thing that we'll focus on is understanding the citations that are there. Let's let the job complete. Okay, there is a question. Meanwhile, this gets completed. There's a question that how you prepare your deck when facing new customers on clients to present about generative AI. Okay, so not related to the session though, this question, but just a second. I'll first run this. Yeah, this is completed. Let me run this one and then I'll answer that question. Okay, I've got the knowledge base ID. Finally, this knowledge base ID is created and it's time to check the knowledge base. Let's run the same query. We are running it and we'll wait for the response. And then after the response, we'll wait for the semantic chunking, how that works. So meanwhile, that is happening. To answer your question, a lot of times customers, every customer wants to go on Gen AI or AI. They just don't know how and when, and they don't even know that whether it relates to their current business model as well or not. So try to understand their current business model, see where these use cases fits, and then using that use case, you can build a deck to provision it. All right, so we got the response and let's see the citations, the chunks that were used to generate for this one. So there were three, and now if you look at it, though I mentioned to use five chunks, I am getting a response as three, only three chunks, because that is what semantic chunking is all about. You are getting chunks which had the relevant meaning for those, and the model was able to pull up this answer from these three chunks only. Not necessarily it has to use all those chunks which you have been given. So even if you are giving five chunks, that use five chunks as the but again, that is your number of results that you are saying five chunks to be used, but only three chunks that were there which contained all the relevant information. So I didn't have to go to the next set of chunks that are there. That's primarily semantic chunking, and you can test it with Retrieve API, same part. Now, the last, not the least, but which is the custom chunking. If I want to not use the predefined strategy, if I want to have my own strategy, in that case, you have a lab given where you can test this out. I'll not run this one right now because I need to cover the responsible AI part as well. On this one, you will see that on the Lambda functions, you in AWS, you can create a Lambda function, and within that Lambda function, and we have given the code for entire Lambda function. If you see it, that in that we have a completely defined in a codified way our own chunking strategy. Okay, completely defining that how you want to chunk those documents. You just need to run this, build it in a Lambda function, and then finally, instead of selecting any of these options, you will select the custom one. If you pass the custom, which means that it will automatically use that. All right. So go through it, do this lab at your own pace, but primarily these strategies that you will hear about are these ones. Okay, now unfortunately we won't be able to cover all the labs today because there is too much, it requires multiple hours. But one important lab that I want to cover is the contextual grounding, and this is going to be our last lab for today's session, today's workshop. All right. Now we saw that in one of the previous slides, and let me bring up that deck as well so that we will see that what this looks like. So in the deck that we were looking at, we saw that, let me put it onto the presentation mode, it's easier. Okay, we saw that we understood about knowledge bases now. We learned about that. Now we saw that RAG in action, how this works. We also learned about the retrieve and generate API, how that works, how it provides context, how it gives response. So I'll not repeat that information, what role knowledge base plays, what is semantic hybrid. We talked about those things. And then finally, we'll be talking about the bedrock guardrails. Now, I briefly touched upon in my initial explanation of RAG that we want to ensure that uh, any question that the user is asking, we need to ensure that it does not contain any harmful content, or it does not gives answer to every question. Not all the questions are supposed to be asked, and all of us are very well aware that what will be those questions that can bring harm to the world, or to anyone else as well. So in those cases, how would you put up those guardrails to not allow the model to answer this? Because a lot of times you would see that people are trying to trick the models and trying to trick the entire flow to get the answers out of it. So again, there is no one stick fits all. You have to continuously train the model, continuously improving your guardrails to stop that. In terms of just stopping that, it also allows you to help remove any PII information. Let's say that I am asking a model that can you share me a contact number of this particular employee, and it has all that company data with it. It knows that in the context retrieval, it will be able to get that information, but I don't want my model to share that information or respond to the user with that information. So how do I stop my model considering my context, my knowledge base actually contains that information, but I still want to stop my model? So that is what we are going to learn in this particular lab, which is about putting up, combining guardrails with your contextual grounding. So grounding is the database that the knowledge base that you are already providing, but how you put guardrails around it. So without wasting any time, let's see on ground how this works. We have gone through this multiple times. We have imported all the libraries that are there. I will not install these requirements again. Let's just set up the path. The path is set. Initiate the Bedrock client session. Again, the time consuming part that we have is creating the knowledge bases. So let's do this. In this case, there is going to be a tricky part. I'll tell you how to overcome that as well. All right, let's do this. And there's a file that we are going to use here. If you copy this URL, open it up, you will see that it's a publicly available file that contains some information related to elf, halfling traits, some random information related to human traits, elf, dragonborn. It's a random gaming related information or system related, but we are just using that information as our knowledge base here. Now, in this step, what I'm going to do it is I'm going to download this file, store it locally here within the same directory because I've set the path for here, and then create a knowledge base and ingest this particular document into that knowledge base. So let's do that. Now, when you run this one, it says that your document is downloaded and it is stored under kb underscore documents. You go to kb underscore documents and open up that document. Okay. The challenge that I have seen in the past is that sometimes you don't get this document downloaded successfully. You might see issues. So it's always good to open up this kb underscore documents and verify that your document is able to open up here and show up all that information, because sometimes it does not get downloaded. If that happens and you are not even able to download it via this command line, my recommended approach is go to this URL, download that manually and just put it into this directory. So that will at least allow you to proceed with your lab. It will not halt you. All right. Now that it is downloaded, let's come back. Let's create a knowledge base. Define my data source, again my S3 bucket, and finally the step where I'm creating a knowledge base. And see that by default, I'm using the fixed size strategy now because we are not learning about chunking here. We are learning simply about how you can put guardrails around it. So let's go ahead, and this is getting created. Meanwhile, let me see if there are any questions that we can answer or have been left out. I think there were a few. We answered this one. All right, yeah. Though this is a bit early for this question, but let's ask this question. Okay, meanwhile, the knowledge base is getting created at the back end. So you want your model to avoid hallucinating or giving irrelevant answers. What features act like as a bouncer at the door? And this gets interesting, like which stops it that no, this should not be entered within the door, or even if it has entered, it should not go out of the door. We are talking about both input and output here. So whether it is going to be guardrails, lambda, cost explorer, or S3 replication. Okay, I see messages coming in, and the answer is A. Most of the folks are saying A. Yeah. So you all are right. The answer is A, guardrails, and that is what we are learning. And focus on the part why we call it bouncer at the door. We don't call it internally, but that's a fun term to be used. You can call it bouncer at the door because it just does not help you with people who what are getting inside, but also what is going outside. And we'll learn about this in this live workshop that we are doing right now, that how that actually works. Okay, this I think will be for structured once we covered. Okay, there's one question left, but we'll cover that later. Let's wait for this knowledge base to be created. And now that we are creating the new knowledge bases, I would highly recommend that for the lab, for the module one, which we did, where we created a different knowledge base, which we utilized for all the labs in module one, you can now actually safely go to the module one and remove those roles and policies and everything. That is absolutely fine. You can either do it by uncommenting this command. You just need to uncomment it and run it. That will do the job for you, because Knowledgebase.py already has a function delete kb which deletes everything for you. Again, if you just want to out of curiosity want to go and see that what is that knowledge base py and delete underscore kb, you can go to this file, delete underscore kb, search for that function. You will see that this is where this function is defined, and what it does, it deletes all those resources for you. Okay, so easy one-stop shop that is being done. This is helpful if you're doing it in your personal environment, so that you don't end up getting more cost around it. Let's come back. Okay, our knowledge base is created. I now upload it. Oh, sorry, I think I ran the knowledge base command again, so it says that it already exists. Just ignore this part. I don't have to run create the knowledge base again. Now I'll just simply upload it to the knowledge base. Now remember that I downloaded files and I'm uploading it to that knowledge base. We are currently in responsible AI. These are the KB documents. I am just uploading these documents. So remember, this is the document that is now uploaded to this bucket, which was created specifically for this particular lab. Let's do the ingestion now. And finally, the most interesting part where we'll talk about the testing the knowledge base. Now, this is where we are going to test the knowledge base based on two things, which is grounding and relevance. How relevant my response should be, and how grounded it should be. Both the cases, you will define the threshold, and you will say that even if it is having the 50% of grounding, it's fine. Go ahead, you can respond to it because that's my threshold. But anything beyond that, no. Relevance, it should be at least zero point 0.8 should be my bare minimum relevance. It is 0.7, don't show it. And we will in our responses, we will also see what is the relevance and what is the grounding. Now, both the things will be directly in comparison to the ground truth or the document that you have provided based on your knowledge base. It will compare the relevance and grounding with that. Let's see, the ingestion job is working on finally. And this is our last lab for the session. But just to give you, while this is happening, just to give you a brief about all the other labs, there is a multimodal RAG lab that is there where you can, how do you process audio videos, how do you process text images, and pretty straightforward. Not as lengthier labs as the previous one. These are going to be very easy for you. So just go through them straightforward, doing the same steps. You won't find it difficult because now you have got the base of it. The only thing that differently that we are doing over here is we are using certain audio files or video files to process. So the major change that you would see over here is that we are using these files, and then when we are processing these files, what is the response that we are getting, that it would automatically be able to tell you that in your audio or video these many segments are there. If you want to transcribe that audio, that is also possible. Those use cases you will come across in these labs. That is primarily about the multimodal one. Then structured RAG, if you have a let's say that if you have a Redshift database or any other structured database that is there. In this case, it expects you to have a Redshift database pre-existing, all right, so that you can utilize it as a source and you can run queries on that database. If you remember the initial discussion which I explained, I'll explain you the most important part, that in this case, what you are doing it is that you will be writing, or user will be writing a query normally in the plain English, but this will have the capability to convert it into a query and then run it on the database for you, so that you don't really have to be aware about all these things. So yeah, I think you see it over here. Yeah, this is the part where you see structured RAG. You enter your simple query over here. It will automatically does everything for you. Same exact structure. All the other steps that we saw previously is just defining it, but this is where you exactly use it. And finally, you see the output in a tabular format, in a column and rows format, which you expect out of any database. You don't need to. One person was asking, probably that was about the file if it doesn't get downloaded successfully. No, you don't need to put it in S3, because you will put it in Jupyter directory, and then you run a command which will upload those files to S3 for you. So there are two commands. One is you are downloading that file. The other is you are uploading it to S3. The only failure that I have observed, which happens very rarely, but just to let you know, if that happens, just put it manually to the Jupyter one. All right. So we talked about structured rack, and then the last is graph rack. Graph rack is a database. Let me show you what it would be much helpful. Graph rack, right? Uh, I think graph DB will give you better response. So yeah, this is the one. So if you look at it, a graph DB basically stores information in a format something like this. It maintains that relationships between the information that you have. All right. So internally, it will contain one to many relationships that are there. And in the AI world, you would see graph DB being used a lot, because it is much more efficient, and it is very much similar to the concept of which we learned about. Remember hierarchical chunking, parent and child relationships. However, in this case, there is no one parent or one child. There could be one to many to many relationships that are there. So, and it's not really just parent child, it's like just having as a relationship one to many wala relationship. All right, then let's move on to this one. We understood about graph rack. This particular lab helps you run all those things in on a graph rack, on a graph DB that is there. So for that, you will actually create a service which is very prominent and available in AWS, is your Amazon Neptune, which you use it as a vector. That is primarily your graph DB, and that is what helps you. This particular lab helps you setting up that Neptune DB, creating same query, running, creating KB using that Neptune DB. Now, the only difference is that here your chunking strategy will change to graph, because now you're working at a graph DB. And rest everything, you can run it, you can run the same query, get the response, observe it, how efficient it is. All the steps are pretty much same. And finally deleting and doing the cleanup of it. Now let's go back to the contextual one which we were doing. All right, finally switching back to the contextual one where we are putting the guardrails. And last lab of the day, you see that our knowledge base is created. We are going to test this knowledge base now. That is the next important section. It's currently running. We have put in a query that what should I know about elves? You remember the document that we provided? That document contained all that information about the elves and everything. So it is able to give that answer because it had that context. It was able to pull up that context and get that answer. Now, how it will work bit differently if I have the guardrails enabled and if I have guardrails configured. Now I see that in guardrail is a separate entity, just like knowledge base has its own ID. Guardrail is also a separate entity. And once you do that, you see that guardrail ID is available to you. And finally, we'll use this guardrail on top of the existing information that we have to basically ground it. Let's do it now. Now I'm running the same query, but this time with a guardrail. I have provided my guardrail ID here, and I have defined the function, and finally let's run it. Now you see that I'm running this query with two different mechanisms, one without guardrail, one with guardrail. So I'm going to get two responses. There are two functions that I've defined. Over here, if you look at it, you see this invoke KB, that is your function without guardrails. And then you have invoke KB with guardrails that contains all this guardrail information. So let's run it and see what response we get. All right. Now, again, a tricky part. When you see this information, you will feel like you see this information. You will feel like that. What was the question that I asked? The question that I asked was, what are high elves? Now, without guardrails, I was able to pull out two chunks which contain some information related to my query, and then my model was able to build information, and in some cases it was able to make up that information as well. Not every information was completely grounded. Some information was made up because it was not even available. Now, with guardrails, if you look at it, I was able to get the same chunks because these two chunks are related to this one, but it simply said that I am not able to sorry, I cannot respond to this one because simply my scores threshold were not met. Okay, my grounding score was 0.34 and my threshold was 5, so it was lower than that. I need to meet at least this score. So even if one of the condition gets fault, even if the information was relevant, but it was not grounded enough, it should be true to its source. So in those cases, you will find out that how you can stop those questions, or you can actually try by. I'll show you a very important part here as well. And let's first complete this one. I think we have another question example. Yeah, this one. Where should the elves go if they arrive in Paris? Very random question. KB might not have all the details or might have all the details. So if you look at it, it does not, even the passage does not provide any information. In with guardrails as well, you're not getting that, but the information is still there because both the parameters are true. Because till the time both the parameters are true, you will see both the responses to be same. But how the parameters will be different, because you need to ask a question which is completely irrelevant for this one. For example, what is, I'll ask a random question, and I'll expect you as well. I'll suggest you as well. Put a random question, whatever that you know of. Try with different questions. See how guardrails come into effect. So, what is quantum entanglement? I'm just asking you a question. Random. Has nothing to do with elves, or has nothing to do with the data that we have in our knowledge base. And let's run this and see how that goes. So without guardrail, I still get some response like the text you provided does not is a concept, is a physics concept, it describing a magical rope of entanglement and all. But with guardrails, it just simply denied to respond. It did not even respond to me because there was no grounding. My grounding is zero. It was not at all related to the content that was there in my suggestion. And you can actually see this as well at the bottom below the grounding scores. Sorry, my bad, it's the scrolling works a bit different. So below the grounding scores, you would actually see that where the guardrail actually intervened, on what message, on what reason it happened. Now you can see that the model actually prepared a response, but it decided not to share it with the user. So if your guardrail is on, it will, even if it has the answer, it will not share it because the guardrail suggests that's not the right thing to do right now. So that is where these guardrails comes into the picture when you want to stop the or avoid the harmless content or any other thing, or the PII information that is being presented. So primarily that was about putting up the guardrails and is being used heavily in the industry now. I think with that, uh, we are at the end of this session and we have covered almost all the important labs that were there. All the other labs that I recommended, you go through it, multimodal, structured, or graph rag, that is as per your own convenience. But primarily we covered all that. Optimizing accuracy, go through the remaining labs of that as well. All right, with that, let me stop sharing. Shweta, you there? Just a minute, folks. Let me check that. Meanwhile, please, unfortunately, due to the time limitation, I have to wrap this session up. But I think we have covered most of the important topics. So I think I'm very confident that if you were focused and paid attention, you will be able to do all the other labs as well. It's pretty straightforward. You are doing almost the same steps, only some different pieces, like you're dealing with audio files, video files, and all that. But I'm confident you'll be able to do it. So, Shweta, with that, we are wrapping up this session. I think we have covered all the necessary workshops that were there. It was nice doing these workshops. And yeah, that's all from my end.
Thank you so much, Sitesh. It has been, I think, more than 2 hours, and thank you so
Yes,
much for taking out the
that's
time.
the pretty longest one that we had so far. But folks on the chat, please feel free to show it on the comments that whether you like this session, whether what
We
more.
still have people who are still like commenting and asking questions, so that's great. I think they have.
Yeah, let me know if there are any open questions. I try to answer questions during the session itself because while the certain transactions were doing,
So I believe, for example, this is one of the recent questions that is there. And if you,
when we feed to LLM about the questions, chunks, and grounders. So next time when we ask another question, does it, all that information? No, it will not have it automatically because see, of course you are doing the ground truth, but you need to keep on updating your ground truth based on the response that the LLM is generating and sending it to the user. You need to do the evaluation. Remember the RAGs that we discussed, the RAG assessment framework. You evaluate that whether it works for you. You find that okay, the agent was able to respond fine, or the answer was correct. Then you add it to your ground truth. So you need to continue updating your ground truth based on the information. If you have a dynamic information, then yes, your ground truth also becomes dynamic.
got it. There is one more. If you can answer this as well.
Formats.
One second. This is not the one. This is what Ananya has answered. What type of
Yes, this is
this
the.
this yes, this was the one. What type of document formats?
Yes, it does. It does support PDF, text, and other. In the sessions, we saw the live examples of how we interacted with PDF, text, and also in the next steps that you're going to do, you will interact with audio files as well. So yeah, it definitely supports different. Oh yeah, we still have the question number 5 left. I will probably I'll cover that. I'll present it in a while. Yeah, but any other questions?
We do have a few comments where people are saying, can we do more workshops with you? So this is something that I just wanted to present to you.
Thanks a lot. Thanks a lot. My pleasure. Hope to do more workshops in future. Yeah. Connect with me over LinkedIn or anything. We'll be able to interact. Yeah.
Great. Then there are some questions around completing the labs. So people who have booked today's slot, they got the access for AWS Workshop Studio starting from 4 p.m. just when we went live, and you have the access for the platform for the next 48 hours. So in the next 48 hours, you can take out the time, complete this entire hands-on workshop, and once you have completed, there are two things that you need to submit. One is the screenshot of the end screen. So once the entire lab is completed, whatever the end screen is, you just need to send a screenshot so that we know that the entire lab has been completed. Second, whatever you have built, the tools and services that you have used, you need to write a blog and publish it on AWS Builder Center. So that blog link can also be submitted on the program portal. And once we have both of the things, the valid submissions will get AI for Bharat certificate for this particular hands-on lab. So this is with respect to the submission requirements to earn your certificate for this week. And for same people who have booked slots for Thursday or for Saturday, you will receive the access code on the same day. And starting from 4 p.m., you can start completing the lab. Since at that point of time, any session won't be live, you can refer to the recording of this session itself, or you can reach out to AWS experts on Discord channel. They would be able to help you with the support queries or anything that is there. I believe, Jitesh, that is all because I saw a lot of questions you have covered during the session itself.
Yes.
So,
Just one last thing before I close this. I want to somebody asked about the last question. So just I want to share my screen one more time. Can you enable? Yeah. Yeah. I think we that was I think this was the only remaining question that was there, right? Question number 5, or was it? No, we covered this one. This was the only remaining one. A user asks, summarize all the financial regulations, but your KB only has HR policies. Now, what should guardrails do? Whether and we learned about guardrails in our last one. So people who are still there active, just message on chat or comment that what is the right answer. Whether it guardrail will query the redshift, it will return any random text, or it will actually block or modify the answer or run a lambda function. Okay, all right. Good to see. Love to see that folks were paying good attention. Yes, the correct answer is actually C. So that actually brings us to the last question. All right, I'll stop sharing now. And thanks, lovely audience. Thanks for being there.
Yeah, people are still answering C. It's great.
Yeah.
Okay.
All right.
Great. Thank you so much for joining, everyone, and thank you so much, Jitesh, for your time. We'll most probably see you in other, hopefully, upcoming workshops as well.
Yes, we'll do. Thanks. Thanks, everyone. Thank you. I'll drop off.
Thank you. Bye bye.